Good morning and thank you for joining. Today we're going to be covering a few items that'll hopefully get you started on Amazon Web Services. We're going to start with setting up an AWS account, and then we're going to dive a little bit into security because it's important that we start using AWS securely. We're going to be creating an identity and access management user and enabling multi-factor authentication, which is a great way to easily really lock down your account. And I'll explain what that is in more detail later. We're actually going to start some instances, which is our word for virtual machines on AWS, and we're going to log into them in real time so you can see how quickly and easy it is to get started and to start logging into instances right away. We're going to have a look at our block storage system, our object storage system, S3 simple storage service. We're going to create a CloudWatch Alarm, which helps you keep tabs on what's happening on your instances and other AWS services in real time. We're going to show you how to back up and restore instances, and lastly, we're going to dive deep into how to keep tabs on your costs so that you know how much you're spending at any given point on AWS. Important thing to remember is that everything we're doing today you can do for free using the AWS Free Tier. It's available for all new accounts for the first year of activation. And so everything that I show you, from spinning up instances to putting up new objects on S3 and exposing them as a website, taking backups, all of this can be done within the free tier. So I really encourage you to take what you learned today and from these slides and from this webinar and go try it yourself. You can have a Windows server or a Linux server up in just a few minutes and not pay a cent. And if you haven't already, I also strongly encourage you to go sign up for AWS. It's also free to sign up. There's a very short process that you go through to just verify that you're a real human being. And then you enter your credit card, but there's no charges to your credit card. It's just to make sure that you are there, and if you decide to incur charges on your AWS account, that we have a way to bill you. So let's have a look at that. When you first go to aws.amazon.com, you can sign into the console or you can create a new account. When you sign into the console, you get presented with the full list of AWS services. Now we're just going to touch a few of them today, including EC2 and some affiliated features of EC2 and Amazon S3. But once you go through that sign-up process, you'll have access to all of these services. You can opt into all of them. Not all of them are included in the free tier, so it's important to carefully read the documentation of the free tier. But the primary services such as EC2, S3, RDS all have a free tier that you can leverage right away to get started for no money. At Amazon, we're really security conscious, and so I encourage all of you to think security first, even if you're just experimenting and getting started with AWS. The first thing you should always do is to create IAM users. That stands for Identity and Access Management. The way AWS works is you have what we call a root account, or the primary account that gets created when you create your AWS account. But we strongly encourage you to create sub-accounts, these IAM users and groups, that allow you to delegate using fine-grained access controls what different people or different systems can do. So for example, you may not want your CFO, who should have access to the billing information, to be able to terminate instances or virtual machines in production. Likewise, you may not want your operations people to see the cost alerts or be able to set those, or maybe you have a database team that is separate from your virtual machine team and you want to keep them separate. Using IAM access management, users and groups, allows you to segregate those functions and to control what people can and cannot do. The other really important thing that you should do when you open up an AWS account, arguably the first thing you should do, is enable multi-factor authentication. Multi-factor authentication, as the name implies, requires that you have another piece, another physical piece to authenticate with. And this could be a phone running Google Authenticator, or it could be a token like a Gemalto token or an RSA key. And basically all this means is that in addition to a username and a password, it's going to ask you in a second prompt for an additional piece of authentication. And you'll see an example of this in a second. This is super important because unless you physically have that phone or the token, then you won't be able to log into the account. And we strongly, strongly recommend that all of our AWS users enable multi-factor authentication so that their account is safe. You want to make sure that you and you alone and the people you designate can use the resources in your account. So let's actually do this. You saw that I just logged into the account a few minutes ago, but let's create an IAM user and enable multi-factor authentication for that user. So first I'm going to go to Services in the top left. I'm going to go to IAM, Identity and Access Management. I'm going to click on Users. And then I'm going to create a new user. Let's just call this one Demo. When you create users, it's going to ask you whether you want to generate an access key for this user. It's important to understand there are different ways to connect to AWS services. Of course, at the base of it, all AWS services are APIs, and then we layer on top of those APIs things like user interfaces or different ways to interact with the services. An access key is kind of the fundamental way that you interact with the APIs and with the AWS services. In addition to access keys, there's multi-factor authentication, user and password-based authentication, and other layers of authentication that you can apply depending on the context. Generally speaking, when you create new users, you want to leave this box ticked and just generate an access key. As you develop your AWS skills, you may branch out from just using the Management Console and start using the command line interface, for example. We have great ones for PowerShell or for terminal like in Linux or in Mac OS X. You need the access keys to use the command line interface. So I'll hit Create, and this is perhaps the most important part of this webinar. We only give you one chance to download your credentials. If you do not download your credentials and you call up AWS support, we don't have them, and we do this very deliberately. You and you alone have access to your AWS account. No one else does, and that includes AWS support. It's the same with the instances, as we're going to see in a second. Once you spin up that instance on AWS, that is yours for the duration of time that you have it running. So for security credentials, it is very, very important that you download them because nobody else has them. It's security by design. If we look inside the credentials file, you'll see that it's just a comma separated value with a username and an access key. Now that we have that user created, the first thing I'm going to do, because this is going to be a user that I'm going to allow for logon, is to manage an multi-factor authentication device. So I click on the user, I scroll down to the bottom, and then I click on Manage MFA Device. In this case, I'm going to use a virtual MFA device, which will allow me to use a cell phone. For example, I use Android, and I'm running the Google Authenticator app on my Android phone. And that is a software way to have a multi-factor authentication device on my phone. Hit Next Step. And then when I have Google Authenticator, unfortunately you can't see this right now, but there's a button I press and I can scan the barcode here on the screen. And then it automatically adds a new auto-rotating token to my phone for this account. Now, importantly, we have just created access keys for IAM User, so that will allow you to interact with the API or to log in using the, or to interact with AWS services using the command line interface. However, it won't actually let you log into the console. So here I can click Manage Password, and maybe create an auto-generated password for starters. Again, we don't keep these passwords, so it's up to you to download them and use them. Lastly, once you've secured the account and added multi-factor authentication, if I was to try and log in with this demo account, I wouldn't be able to do anything because I don't have any permissions. So here you can attach a policy and choose what type of permissions to add. You'll notice that these policies have a little Amazon AWS square on the left-hand side. That means that they are AWS managed. They're not custom policies. They're pretty self-explanatory. If you want to give someone all access to every service, you give them administrator access. If you want to give them just access to one service, for example, the ability to spin up new instances, and that's it, you can just select that. Hit Attach Policy. You can do multiple ones if you want. Now that user has EC2, which is our virtual machine or instance service, full access. So if I was to log in as demo, I would only be able to use the EC2 AWS service. So once again, just to reiterate, I created a user. I associated a multi-factor authentication device. I optionally created a password so they could log into the management console, which is the web interface you see here. And then I attached a policy so that they'd have permission to do something. We have something called least privilege at AWS, so by default, users have no permissions. Let's go back to the presentation. When you spin up an AWS EC2 instance, you need to get onto it somehow. It's remote, it's running in our data center, so you need to be able to log on to that instance. So if it's a Linux instance or a BSD instance, you use something called SSH, so Secure Shell. The way that you authenticate with Secure Shell on AWS instances by default is using something called keys. So when you create an EC2 instance, you associate a SSH key with that instance, and that key will allow you to log in securely to the instance remotely. Using keys, at least at small scale without MFA, is a way to avoid password weaknesses so that someone can't copy your password, or you may scribble it down on a napkin. You don't want someone being able to have access to your remote instance. There are other ways to secure your instance, like security groups that we'll talk about in a second, but having a key file that you download on your machine and keep it there is one easy way to secure your instance, because they'd actually have to have that key file to log into your AWS instance. So let's do that first before we go and create the key, or before we go and create the instance. So I'm going to go to Services, and then EC2, which is our virtual machine or instance service. I'm going to scroll down to key pairs here on the left. I'm going to go create key pair. Give it a name, demo, then create. Now you'll notice that the key just downloaded. So that is the private SSH key that just downloaded to my computer. So using keys is one way to secure your AWS instances, but another way is through network security. So we have this concept called security groups, and they're essentially firewalls for your instances or for your VMs. Just like the way IAM by default has no permissions for users, security groups also take that least privilege approach, and by default, security groups block everything. So you have to open up individual ports so that you can get through to the instance with various protocols. So for example, if you want to get in using SSH, that corresponds to TCP port 22. Likewise, if you want to have access using RDP, then that's TCP port 3389. You also get to choose which addresses the ports are open to, and you use CIDR rules to decide which address space or individual addresses can get access. And this will make more sense in a second when we have a look at it. But long story short, what we're doing is deciding on a per protocol basis who and what can get at that instance. And by default, everything is locked down. So let's create a security group. I'm still in the EC2 Management Console here, and I'm going to click on Security Groups. Then I'm going to go Create Security Group. I'll give it a name, Demo. Give it a descriptive name or descriptive description that tells me what I'm going to be using it for. I'm going to add a rule. I'm going to say, just allow SSH from where I'm sitting right now. Just be very sure sometimes when you're behind a firewall that this IP isn't auto-detected correctly, so make sure that this is the correct IP. Now I could put a range in there. For example, if it was a local network, something like this, or a public IP address if I knew the public IP address of my internet-facing router. We don't really recommend doing anywhere, but sometimes you may have additional security controls in place, or you have something like a bastion host, which is like a gateway to your environment, and on occasion allowing access from anywhere, which corresponds to 0.0.0.0/0 is okay. But generally speaking, we encourage you to, again, take that least privilege approach and only let users and networks in that you trust. Now what we're going to do is start a new instance. So instances, again, a reminder, are virtual machines that are running in the cloud. Like I said earlier, you have full control of the instance and can install any software on the instance that you choose. So this means that you and you alone have administrator or root access to the instance. And again, if you call up AWS support, they don't have your keys, they don't have your passwords, they have no way of getting into your instance by design because you effectively own that instance for its lifetime when you run it in your account. So you basically define what kind of machine you want, and by that I mean what size, how many virtual CPUs, how much memory, how much disk space, etc. you want. And then you decide what operating system it's going to run. Then you associate it with a key pair and connect it so you can connect to it via SSH. The key pair is also used to decrypt the Windows administrator password. Lastly, you choose a security group that you're going to put your instance into. So again, security group is sort of like a firewall, so you can define a range of IP addresses or IP ranges that are allowed to access over certain ports to your instance. So you're saying who can log in with the key pair, or what key pair can log in, who can log in from what network, and what kind of size of instance you want and what OS to run. So let's see what this looks like. I'm still in the Amazon EC2 Management Console. I'm going to click on the Instances link on the side there, and then Launch Instance. So the first step is to choose your operating system. Generally these days, that acronym HVM on the side, you're going to want to launch HVM instance. There's another that you might have seen called PV, and these days, for almost all purposes, you're going to want to launch the HVM instances, and that's why they're first. Most people don't need to care about that, and you just need to care about what OS you want to launch. We have many flavors of Linux, we have BSD, we have many different types of Windows, like Windows Server 2012, 2008, some that come included with SQL Server Express, and more. Today we're going to launch a couple. Let's start with Amazon Linux, which is Amazon's own flavor of Linux. And for those of you who have used CentOS or Red Hat, it uses RPMs. It's going to be very familiar in that sense to you. Next, you get to the type of instance. The important thing for you to note when you're getting started is that label that says Free Tier Eligible. T2 Micro is our smallest instance type, and it's kind of interesting because while it has very little memory and virtual CPUs relative to other instance types, it has something called a burst capability. So in fact, it can run pretty fast for short periods of time. So it makes it great for testing because you can run some pretty serious applications and certainly enough to power the operating systems and basic applications for limited amounts of time at quite high speed. And then it gets throttled back once you run out of credits. So while we don't recommend using T2 Micro for production workloads, it's a great way to get started and a great way to learn about AWS. I'm going to pick a T2 Micro for this first test. Hit Next. Then you choose what VPC you're going to put it into. For most people, this is just going to be the default. VPC is our virtual private network, so virtual networking construct, which essentially assigns private addresses to your instance. Most people don't need to worry about this when you're just getting started. You just want to make sure that you launch your instance into a public subnet. So it has a public IP. Here it says auto assign public IP, and you need a public IP because if you want to connect to it over SSH or over Windows over the public internet, it needs some way to find that instance over the internet. We don't have time today to get into a lot of the other nuances like IAM roles and all the rest, but I encourage you as you start doing this discovery with the free tier to have a look at all that. Next, you decide how much storage to add. By default, Linux instances come with 8 gigabytes of root volume storage, and Windows instances need a little bit more for the OS, so they come with 30. One thing that's important to note here is volume type. We have 3 basic EBM volume types, and I'll discuss those in more detail in a second. Again, for most people, the general purpose SSD volume type is the most appropriate. It's quite fast, it runs on SSDs, it has burst capabilities, and so it can run for short amounts of time at higher than base I/O. So it's a good place to start when you're getting started. Last but not least, you can tag your instance, and this is really good for keeping things organized. We use tags for all sorts of reasons, from billing to fine-grained access controls, but also just so you know what's running on your instance. So I'm going to call this one demo. Last but certainly not least, you apply a security group. And this is what decides who can get access to this instance. And in this case, I'll say it's a Linux instance. I'm going to give SSH access, and I'll do from my IP. Hit review and launch, and then launch. Now it asks me, okay, I'm about to launch this instance. What key, what SSH key pair do you want to associate with this instance? And remember when we created that SSH key pair, we downloaded a file. In fact, you still see it here on the bottom of my screen called demo.pem. So I'm going to select key pair demo, and this means that I'll be able to log into this instance by specifying this key file. And it's really the key to the lock to allow me access to this instance. That's it. Now if I go back to instances, you'll see that demo is already starting to launch, and in about maybe 20, 30 seconds, it'll be ready to go. So while we wait for that instance to start, let's pivot and talk about another equally important AWS service. It's one of the original AWS services from over 8 years ago when we first launched. The simple storage service is an object storage system, an internet storage system for pretty much anything. It's a really, really affordable place to store any amount of data. You can have objects, very large objects. You can have terabytes and terabytes of data stored in S3, and it just costs a few cents a gig. What makes S3 special is its durability. It has 11 nines of durability, and it can scale effectively infinitely for most users. And by that I mean that you can have many, many, many users uploading and downloading at the same time and not sacrifice performance. We architect S3 to have 11 nines, so 99.99999% durability, and it also has some pretty good SLAs around availability. So it's a really reliable and fast place to store your data. Encryption is available both on client side and server side, and we isolate storage by AWS Region. And if you're new to AWS, a region is a collection of what we call availability zones, and each availability zone is one or more data centers. So we achieve that durability target of 11 nines by replicating and by spreading objects across multiple data centers across a wide geographical area. So every time you put a single file or single object in S3, it gets spread around automatically across many disks and many data centers. Just like EC2 you saw with security groups and IAM, you can also get very granular with fine-grained object-level permissions. So for example, if you have a bunch of objects in what we call a bucket or a top-level folder, you can be very specific about who can access what. Last but not least, it's easily accessible. A lot of the programs that you may be using already on your laptop, things like FileZilla, I think supports it. I use CyberDuck on my Mac, already support S3, just like they support FTP. So how does it work? Well, let's have a look. So I'm going to go to Services, and then S3. So you may have heard me just say it. We have this concept called bucket. And think of bucket as kind of a top-level folder on your drive. It's important to note that we have a hard limit of 100 buckets per account. And so don't create a bucket for every single use case. Create essentially subfolders, which are represented by prefixes. I'll show you in a second. If you're going to have a lot of files, every time you need to upload an object or have a new project, don't create a bucket for that. You might have a bucket called projects, for example, and inside that project bucket, have all of your projects listed as what effectively looks like separate folders. So when I create a bucket, I'll call this one demo. It's going to ask you what region do you want to put this bucket in. And remember, S3 replicates objects to get that 11 nines of durability across multiple data centers, so multiple availability zones, multiple facilities within a region. So in this case, I'm sitting here in New York, so I'm going to pick the US standard region, which is on the East Coast of the United States, and then hit create. Oh, I did that on purpose because bucket names are globally unique. And That's not just limited to your account, but globally as in the whole world. So when you give your name a bucket, you need to use a unique name. So if I call this, for example, demo mat 03, or sorry, 2015-0317, chances are when I hit create, no one has used that bucket name before. So now that I've created a bucket, I can upload objects into it. You can use the command line for this, you can use the API for this, you can use the web interface like I'm about to. You can also use programs that I mentioned earlier like CyberDuck and many programs like Cloudberry Pro that support S3 as a file target. So let's hit upload and then add files. I have a little image file here. Let's start the upload. Importantly, and you're going to start to see a theme here, like pretty much every other service on AWS, we start with a principle of least privilege, which means that by default, this object is only accessible by me. So if I wanted to allow other people to download this object or interact with this object, I'd have to go to Properties and Permissions, and then add more permissions. This is my username for this account, and only I can manipulate this object. So I'm going to add some more permissions here and say everyone can have a look at this object, not necessarily delete it or change it, but can see it. Let's save. Now when I click on this link for this object, there we go. Now that's over the public internet with no authentication. You may notice that the protocol being used here is HTTPS. And so the savvy among you might be asking yourselves, well, isn't this effectively a website? Did I just create a website or at least an object on the web? Well, the answer is yes. Hence the name, Amazon Web Services. S3, as it turns out, is a great place to host static websites. Personally, I run about 9 websites last time I counted, and I host them all on S3. In fact, none of them have servers. I host all of the JavaScript and HTML and PNGs and JPEGs on S3 and S3 alone. And I use S3 essentially as my web host. My total AWS bill never comes to more than $5 a month for 9 websites. So S3 is an incredibly affordable place not just to archive or store data, but also to host static websites. We're not going to spend the rest of the time talking about static websites. I could go on at length, but I just wanted to put that bug in your ear that S3 is increasingly a place where people are affordably and in a durable and high performance way hosting their websites. Great, so let's go back to the EC2 console for a second and look at that instance we just created. But before we go there, just to reiterate how we're going to connect to these instances. So we have spun up these EC2 instances and they're remote, they're running in AWS data centers, so we need to get on them somehow. So for Linux and also for BSD, you can use SSH or Secure Shell, which is really the way that most people using the console or terminal would get at their instances. Windows users, one option is to use Remote Desktop or RDP. That's probably the most common way to remotely connect to Windows instances. And you can use either of these common methods to connect to your servers that you launch on AWS. So specifically, when you use SSH with AWS, you use the command SSH and then -i, and you specify the key file. Remember that demo.pem private key that was downloaded. And then something that people often forget at the beginning is don't forget the username. When you launch an Amazon Linux instance, the default username is ec2-user. It's important to note, though, that this is not the same user for all operating systems. If you launch some older versions of Red Hat, I believe the username used to be Red Hat. Ubuntu, the username is Ubuntu instead of ec2-user. So when you launch a Linux instance, just remember to check what user is associated with that operating system. And then, of course, the public DNS name or the public IP of the instance that you just launched. If you're connecting to a Linux instance using Windows, most people use a program called Putty. The important thing to remember about Putty is that it doesn't use .pem files for the private key to connect via SSH. It uses something called PPK. So you'll need to download a separate file called PuttyGen that converts the PEM file that you downloaded from Amazon to a PPK. There's other SSH clients for Windows that do support PEM files. Personally, I like Git Bash, which is the MinGW SSH client for Windows. and that can then just use the PEM files without having to convert them. But Putty is by far the most popular, so that's why I wanted to put it up there. When you're connecting to Windows, I think most of you probably know how to use remote desktop, but if you don't, you can use it just by typing the command mstsc and then /v : the IP address of your instance. The username is always going to be administrator, and we'll see how to find the password in a second. So let's do that. So I'm going to go back to the EC2, Amazon EC2 page on the Management Console. Now I have this instance I just spun up and it's running. So you can see how quickly and easily it was to spin up a Linux instance on AWS. But I actually spun up some ones earlier that I tested, and because we're on live here, let's switch over to the Oregon region where I just a few minutes ago started a Amazon Linux instance and a MS Windows instance using an example.pem file that I downloaded to my desktop. So with Linux, you'll notice that it has a public IP, and if I hover over security groups, or view rules rather, you'll see that I have a rather permissive, quite honestly, security group rule here that allows TCP port 22, which is SSH, from 0.0.0.0/0, which is just a fancy way of saying from anywhere. So I have the security group SSH from anywhere associated. The key I've associated with this instance is example. So I have an example.pem file that was downloaded to my desktop. So if I list my desktop, you'll see I have that example file. Now let's go back to the instance. Let's copy that public IP. I could also use the public DNS name. And I'll do SSH, and I'll specify the PEM file. And this is an Amazon Linux instance, so I'll use EC2-user, and then just paste in the public IP address from the console. And there we go. Now I'm in my Amazon Linux instance, and I can do, a yum update or whatever I want to do, install software. And there we go. So let's flip back to the Windows instance. Very similar process here. What's changed though is the security group has changed, because we're not going to use SSH to connect to Windows, we're going to use remote desktop, and that runs over a different port, it's a different protocol. The public IP and the DNS are also different, so if I hit view rules on the security group, you'll see I have TCP 3389 allowed, in this case from everywhere, probably not the best idea, but okay for a demo. And here's the public IP. So if I flip over to remote desktop for OS X, let's close that. Here I created a new entry. I have the IP, the username's administrator. Now how did I get the password? Because if we can't specify a key, how does it work for Windows? Well, if I return to the console here on MS Windows instances, when you right-click, it gives you the option to get Windows password. And in fact, this is why I spun up a Windows instance ahead of time, because Linux instances just take maybe a minute or two to initialize and to get started, and then you're able to SSH into them directly. With Windows, it takes a little longer, sometimes up to 15 minutes, because it has to reboot multiple times just due to sysprep and other activities that happen when you initialize a Windows server. So that's why I prepped this one just a few minutes before the webinar. Once the instance is initialized though and has gone through its provisioning phase, and you can right-click on it and then get Windows password. It's going to ask me, you associated the key pair example with this, so where is that key file? Well, it's on my desktop, so let's go get it. Then decrypt the password, and then it gives me the administrator password. And that's how I got it to connect. And there we have it. Now I'm connected to a Windows Server 2012 R2 instance that I just launched a few minutes ago on Amazon EC2. If this seems a little complicated to you, or if you don't have Putty installed and you're not really sure about SSH, or you just want to try it out, another way to do it is to connect directly from the AWS Management Console. So returning here, if I right-click on this Linux instance, for example, I can hit Connect. So this will actually give me pretty specific instructions on how to do it, but it can also launch a Java SSH client. Then I can specify and this will take a moment and launch a Java container that will open an SSH window. So again, this doesn't require you then to install an SSH terminal ahead of time or an SSH program ahead of time. So now we've seen how easy it is to log on to the AWS Management Console to start storing some object on S3, and also how to start spinning up servers on EC2 and connect to them via SSH and remote desktop. So how do I keep tabs on these servers? How do I watch what's happening? Well, that's where CloudWatch comes in. CloudWatch is a service that we have that gathers metrics on your EC2 instances and on a lot of other AWS services as well. So it's also a way that you can react to issues with your instances, or maybe not issues. Maybe you just have a lot of users or a lot of usage on that instance and you want to add more or increase the size or just change your environment in some way. So CloudWatch allows you to both get alerted when you're using your instance more than it should be at near capacity, but also automatically take actions. For example, you can use auto scaling, which is another AWS service, to add additional instances to spread the load out if your instances are collectively reaching a threshold that you set, such as average CPU utilization across multiple instances. You can also shrink, and I think this is really important when you think of AWS. It's not just about expanding as usage grows, it's also about the ability to shrink. Because you only pay for what you use, you pay by the hour with EC2 for on-demand instances. When your usage shrinks, for example, maybe 5 p.m. at 6 or Friday at 6 p.m. when everyone goes home, you don't need as much capacity on the web front ends of your SharePoint site. So you can auto shrink it as usage decreases, and you'll save some money because you're not paying for that capacity that you're not using anymore. So let's create a CloudWatch alarm so you can actually see what I mean. So I'm back on the Management Console. Oops. I'm going to go to Services, close this Java window, and then CloudWatch. And then there's a button on the far right, Create Alarm. There's a lot of metrics that CloudWatch tracks, and by default we track them in 5-minute intervals. But when you go and launch an EC2 instance, you'll notice that you have the ability to turn on enhanced monitoring, which gives you minute level granularity, so you can have quicker reaction time and detection time of metrics. But by default is 5 minutes for EC2. So I'll click on EC2 metrics, and here is a list of different metrics that I can track, such as disk read and network in, network out, CPU utilization. Most people will typically monitor network, CPU, and to some extent disk. Let's go with CPU, and I'll hit next. I'll call this CPU over 60. So when my CPU utilization is over 60% for 3 consecutive periods, so that's 15 minutes, that's probably a long time, do something. And what can I do? Well, I can send an alarm. I can take an auto scaling action where you can add or remove capacity like I was talking about before. When you're first getting started, most of the time you just want to have an alarm. You want to get an email or a text, and we use our simple notification service, which is tightly coupled, or which is nicely coupled with CloudWatch to send you those notifications. So in this case, I have a preset notification, send me an email, which is just a topic which has my email address in it, so that when I hit this threshold for 3 consecutive periods, I will get an email saying, hey, this instance has been running hot for over 15 minutes. I'll create the alarm, and that's it. The first few minutes, I'll get an insufficient data warning because it needs to collect the metrics before it can give you accurate information. But that's how it works. Very simple. Gives you a lot of flexibility. The important thing to know about CloudWatch, though, is that you can also add custom metrics. The metrics that we have in there, like CPU, disk, are good enough for most people. But what if you need something like the amount of users connected to my application, or something that we can't see because we don't have OS level visibility, like memory usage or disk usage? You can actually surface those using very simple scripts and the command line interface or your own tools to CloudWatch as custom metrics that you can then set alarms against and do other things. And the time that I've been rambling on here, the alarm has gone to OK state because it has enough information. And you can see that my CPU is well below the threshold, so I won't be getting any emails. So a reminder, the most powerful combination is the auto-scaling service with CloudWatch. When you hit thresholds, for example, CPU utilization across a fleet of web servers, add more of them. So it allows you to scale to meet demand. And because you only pay for what you use, you only scale for the time you need to meet that demand, and then you can scale it back once you're done. So really, this is where the cloud becomes the cloud. When it becomes powerful, it is the flexible model that we have to add and remove capacity as required on demand. So we've talked about object storage, we've talked about instances, and we've talked about how to monitor those instances, but what about the actual block storage associated with those instances? S3 is not block storage, it's object storage, and it's eventually consistent. So the super high durability and availability and performance of S3 does come at a cost of consistency. That if you put an object into S3, there may be an extremely small delay, but a delay nonetheless, before other people can see or interact with that object. If you've ever used databases or any kind of high performance application that uses block devices, you'll know that that consistency attribute of S3 is going to make it unsuitable for certain types of workloads, notably hosting an operating system or running a database or things that need to be in a consistent state all the time. More importantly, operating systems like Linux and Windows are built to run on block storage. So that's why we have this service called Elastic Block Storage. There's two types of block storage on AWS. There's ephemeral storage, which is the storage that comes with your instance. And then there's elastic block storage, which is decoupled from the instance. So the storage lives separately from your instance. If you stop your instance, and when you stop your instance, you stop paying for it, elastic block storage will live on. Whereas the direct attached storage, the ephemeral or instant storage, if you stop your instance or if you terminate your instance, that storage goes away. So EBS is a way to nicely decouple your storage from the life cycle of your EC2 instance. So you can remove volumes, you can reattach them, you can take snapshots, which you'll see in a second, and you can create custom volume sizes and performance characteristics, and again, only pay for what you need in terms of size and also performance. We have the relatively new general purpose volumes, which give you SSD type performance, but not at the price that you previously had to pay for provisioned IOPS. If you're running high performance databases that need really predictable I/O, the provisioned IOPS EBS volumes are the best choice. But for most people, the general purpose SSD volumes are just perfect for about everything. And then there's the old volumes, which are the magnetic volumes. Just think of them as traditional spinning disk magnetic volumes. Like in the old days, you still have access to those in EBS, but we don't really recommend them for general purpose use anymore. They're for use cases where you may not require the performance that the general purpose gives you, and you want to save a little bit of money. Again, for most of you starting, the takeaways here are use EBS for any storage that you care about because it lives outside of the life cycle of the instance, and you can more easily snapshot it, take backups, and interact with it than you can with direct attached storage. And use general purpose volumes because they're pretty much good for almost every workload. So let's look at backing up an EBS volume. So before you saw I spun up those two instances. Now EBS is tucked away in the EC2 section of the Management Console. So I went to the EC2 Management Console page, and then here on the left-hand side you'll see Elastic Block Store EBS, and I can click on Volumes. I have a couple volumes there. Now these correspond to the root volumes, or the C drive for Windows, or the slash, top-level slash in Linux. And I have one that's that root volume for Linux, which is 8 gigs, and the root volume for Windows, which is 30 gigs. Now what if I've done a lot of customization, or I've installed a lot of software, and I want to take a backup of that, a point-in-time backup of that EBS volume of Windows, for example? Well, I click on the Windows volume, I right-click on it, and I create a snapshot. Give it some kind of a unique name so it makes sense. And hit create. Simple as that. So EBS will go and do a point-in-time snapshot of that EBS volume. Now importantly, subsequent snapshots of that volume will only take the changed blocks. And those snapshots are stored in S3. Now you do pay for the snapshots on S3, but S3 is so cheap that that barely figures on your bill. So you can take very low cost, highly durable backups of your EBS block storage devices. And then for subsequent snapshots, because they only take snapshots of the changed blocks, you pay very, very little overhead for keeping incremental backups as you go along the lifetime of your instance or your application. If I go on snapshots now, you'll see that that snapshot is being created. It gets created in real time. You can continue to use your volume while it's getting created. So it's a great way to take low overhead, highly durable backups of your block devices, like your operating system and applications that you install. So that's fine about the volume itself, but what about the whole image that you've created for your instance? For example, say you have a Windows instance and you install some software, you customize the OS, you tune the TCP stack so that it performs well, you do a bunch of stuff that took you a lot of time, and you want to be able to relaunch instances just like that without having to go through all those configuration steps again. Well, that's one good example of where a custom AMI is a great idea. AMI stands for Amazon Machine Images, and just like at the beginning when we went to launch an EC2 instance, it asked us, what AMI do you want to use? What operating system? We have base AMIs with things like Amazon Linux and Ubuntu and Red Hat and Windows. And then you can build on top of those base AMIs and create custom AMIs from them. By default, they're private, but you can share these AMIs with other people. So let's create an AMI of that Windows instance or Linux instance that we launched. So I'm going to go to the EC2 Management Console and go to Instances. This time, why don't we do Linux? I right-click on the instance. Now everything I can do, I can right-click, or I can go to the Actions menu. I'm going to go to the Image menu and then Create Image. Give it some kind of a recognizable name. Usually the defaults are fine, but you can tweak it if you want. For example, if you wanted to change, if this was originally a magnetic and you wanted to upgrade it to a general purpose, you can change the size of it for next time it gets launched, and then create an image. Now this is different from an EBS snapshot because an EBS snapshot is just the volume itself. You still need to attach it to an instance running. Whereas the AMI is the whole instance, and you can use an AMI to launch net new EC2 VMs or EC2 instances on Amazon. So that's it. Now if I go to the AMI section here, you'll see that this is creating. And now I have a backup of my customized image or my customized VM that I can use to launch similar ones going forward. So lastly, we're going to finish with billing and cost management. And we've gone through a bunch of topics like IAM and S3 and EC2 and EBS and backups. But some of you are probably wondering, well, this is great, but once I get started, once I move beyond free tier, I want to keep very, very close look on my spend. You know, I mentioned earlier that I only spend, I think these days it's actually something like $3.60 a month on my personal account, and I host 9 websites on S3. Now, believe it or not, I have a billing alert on my phone that buzzes if I go above $5. Because as a solutions architect, I'm quite proud of what I can do for $5 or less on this web hosting account that I have. Now, I have other accounts, of course, that run in the tens of thousands a month, but that's beside the point. For this $5 account, I want to keep very close tabs on it. So how do I do that? How do I, as my organization adopts AWS more widely, how do I keep tabs on who's doing what it's costing, how the costs have changed? How do I set alerts so that I can get proactive alerting on spending limits, not just usage? And then how can I drill down into the bills? So let's look at the AWS Account Billing Console. First of all, what we're looking at here is a single account. For more complex enterprise deployments, or if you have mergers, or for all sorts of reasons, you may have multiple AWS accounts. We have a concept called consolidated billing, where you can have a master payer account, and then under that have associated accounts that roll up to a master bill. So if you're interested in this, I'm not going to show it on the demo today, I encourage you to look up consolidated billing in the public AWS documentation, and it's very easy to get started and to get that master payer account created and to roll up your bills into a single bill. It'll give you much better visibility. My only tip, if you do that, is to, as a second move, once you create it, to look into tagging. because you should start to use the tags just like the name tag and other tags, for example, for cost center or department, and those tags get surfaced on your bill. So especially as you start to grow your AWS usage and grow the amount of accounts you have, you want to be able to easily identify those resources across different accounts on that master bill, and tagging is the way to do it. But for most of us who are just working out of a single account, click on your name in the top right, and there's a relatively new link here called Billing and Cost Management, and it's a new interface we have that ties together a lot of the billing and cost related services and features that we've had in different places in the past. Now this is my demo account, so I have a relatively low spend. It shows you pretty easily kind of what services you've been using, how much you've been spending, how much it is relative to the previous month. One thing I wanted to highlight is Cost Explorer. Cost Explorer is a great way to get some more visualization, a more fine-grained breakout in terms of what your usage is on AWS. So here we can see I've been using this account for the AWS Kinesis service a lot, and you can get a more broad range of how I've been spending. In this console, I can also download bills, look at settings, etc., see more detailed reports, everything that your CFO would want to see to understand the AWS usage. The last thing I wanted to show you before we finish out here is billing alarm. You see I haven't set a billing alarm here, so if I go to if you've never set it before, just go to the cost management dashboard that we're looking at now under your name, and then click on Set Your First Billing Alarm, and then Create Alarm, and this is where I set that $5 threshold. It says Send a Notification to, you can say a new list. I can put my email address, and create an alarm. That's it. Then it'll send me a confirmation address. Once I confirm that confirmation address, if I go over $5 for the month, I'm going to get an email, a really great, easy way to get started with cost management on AWS. In fact, I just saw an email pop up on my phone. I just got one because I'm already at 15 bucks. So that's it for today. We still have a few minutes for some remaining questions. I'm sure Hans has been busy answering your questions, and if you haven't submitted any, I encourage all of you to submit questions to the question pane. But just to get back to what we covered setting up an AWS account, creating an IAM user, and securing it with multi-factor authentication. I can't emphasize this enough. And remember, multi-factor authentication is both for the root user, which is the user that you originally create your account with, and for subsequent IAM users. Really, really important. We covered creating key pairs and using them to unlock administrator passwords and log in over SSH to Linux boxes. We covered how to replicate firewall-like functionality using a security group. We started a couple instances and we logged into them. We created our first website on S3 by uploading a simple picture and locating it using the HTTPS endpoint. And lastly, we drilled into monitoring from a billing and from a metrics utilization perspective on our EC2, EBS, and other instances and resources that we spun up. So I hope that you got something out of today's presentation, that you're excited to go try out your free tier. And again, I can't say this enough. The best way to learn all of this is just to try it. Everything I showed you today you can do for free. And if you do start using AWS more heavily, I think you'll be pleasantly surprised by how affordable it is. In fact, it costs pretty much pennies per month to do some pretty incredible things. One important thing to know about the free tier that I think a lot of people don't realize up front is for the Amazon EC2 service, you get 750 hours for free per month for your first year. But you can divide that however you want. So you can have 10 instances using 75 hours, or you can have 100 instances using 7.5 hours. So you can have a cluster for free of T2 micro instances in your first year of AWS. So thank you all for joining. We'll continue to answer questions as we go forward.